So I posted more practice problems about rotation matrix, exponential coordinates, just to help you out. I picked those from your books, textbooks, questions, exercises. So if there are other exercises that you try to do and then you're not sure of your solution, just email me your solution. I will check with the solution manual. All right. So don't forget, your textbook is a supplement material. I expect you to go over the sections and do the examples. If there are sections I don't want you to study, I will tell you, like wrench that we talked about, right? And the no screw axis. Twist. I mentioned twist, but I'm not expecting you to solve the problem of twist, because then you have to get the adjunct of a matrix to calculate things. We don't need it now. We're going to go back to it later. So I think those the only two that I don't want you to study are those. Everything else you should be following the book also. All right. So my suggestion is look at the questions first. Try to solve a couple, and then go and check the solution, that at least if your train of thought was correct, like the way that you approach that question was correct. So don't go jump and check the solutions. All right, let's get started. Fred, can you tell me when it's 3:30?
Yeah.
All right. All right, so last class, we solved an example of forward kinematic, and we got to an expression for forward kinematic that had e to the power of s bracket theta, right? So for every joint, you will have that is your screw axis. So that's the exponential coordinate of that screw axis. Now, how do we solve that? You will get a programming assignment next week that you basically are gonna code that. So you can just use your code if there was any assignment about calculating to the exact matrix. All right. If you are going to do it by hand, how would you do? Or this will be the algorithm for your code as well. We can use Rodriguez's formula, and it said that given a vector omega theta, so that is our omega is our axis, theta is the joint variable. We know that rotation of theta and omega and theta is equal to e to the power of theta omega. So this is a 3x3 matrix, right? We are still on rotation for now. You can calculate the expression on the right, and it will be equal to the left. To prove that, go to your book, and the proof is there. So if I is the identity matrix, it's 3x3, right? Because the other side is 3x3. Plus sine of theta, these are in degrees. And then that is skew symmetric of omega. So you know how to create that. Plus 1 minus cosine of theta is skew symmetric matrix with power of 2. So if you calculate that, you will get the rotation matrix. So this means that if we have an omega, an axis, and a rotation, we can represent the rotation matrix of this. So let's say that I'm telling you, hey, rotate this frame S about that axis omega by 30 degrees, right? So this is not about like your principal axis. So you can't really visualize anything. You have to calculate. The way to calculate it and represent it in matrix form is to follow that formula. So let's do that. Our rotation will be rotation omega 1 and 30 degrees. I can write it as I plus sine of 30 degrees. This is a skew symmetric of omega 1. So I have 3 components, 0, 0, 0.866, and 0.5. So 3 elements, I can create 3x3 matrix plus 1 minus cosine of 30 degrees multiplied by omega 1 skew symmetric to the power of 2. So you will get something like this. 1, 0, 0, 0, 1, 0. So this is your identity, which is 3x3, because we should be able to add. So this is 0.5 And here will be 0, negative 0.866, 0.5. And then this is just the mirror of that, 0, 0. This is the mirror of that element on top, 0, 0. And we have zeros on the diagonal, so it looks good. Plus 1 minus cosine of 30. Cosine of 30 is 0.866. So will be 1 minus 0.866. And then I'm going to cheat here. It's faster. Paste. Move everything probably down here. Nope. The power of 2, don't forget that. Now you will get your final matrix, 3 by 3. I posted the solution in annotated version, I'm not gonna write it, but there will be 9 elements. So this is the matrix representation of that rotation along a random axis. So you remember previously, if we went over, if we get the rotation matrix, how to calculate our axis and angle. Remember, lecture 7, you had to calculate theta and k. So you had to find the trace and then do cosine inverse of trace minus 1 divided by 2. And k was 1 over 2 sine of theta that you found times, then there was, I think it's r minus r transpose. That's how that bracket is created. So you found theta and r, theta and omega. So now you know both ways. If you have a matrix representation, you know axis and angle. If you have axis and angle, you can find this one. So now you can go from both ways. Cool. So this is for rotation matrix. Now we're going to use this Rodriguez formula to find that e to the power of s bracket s theta. All right. Because if you remember in that bracket s, we had a skew symmetric of omega and v, right? So are you writing these? It is, we have it in the annotated version, but if you want to write, I'll give you a few seconds to do that. Yes.
My first one is symmetric. So when you were writing the negative 1, you added a negative 0.8 and the positive 4.5, and then the opposite of that.
So remember, if this is your omega, you have omega 1, omega 2, omega 3, and then the skew symmetric of omega is 0, 0, 0. I think it was omega 3, negative omega 3, omega 2, negative omega 2, omega 1. Was it negative omega 1, omega 1? Can you check lecture 1 or 2? So whatever, there's a, I don't remember which one is which, but yeah.
So the top middle one, the negative 3,
Okay, so is the first one omega 3, omega 2? This one. So this is negative. Yes. And this one is omega 2, negative omega 2. And then this one is omega, negative omega 1, omega 1. Yes, okay. So yes, this then would be the other way around. Yeah. So omega 3, negative 0.5, 0.5, then is 0.866, negative 0.866, and fill that out yourself. And then you'll get, I'll check the final solution because right now my current solution is wrong, but doesn't matter. All right, thank you. Okay, so this is the Rodriguez formula. All right, any confusion what happened? I just misplaced omega 2 and omega 3. All right, now if we want to find a closed form expression for matrix exponential e to the power of s theta, we can directly use this expression. Now, given that s is your screw axis, it has 6 elements. The first 3 are your angular velocity. The last 3 are your linear velocity. So if omega is 1, And so basically square root of omega 1 square plus omega 1, omega 2 square plus omega 3 square, right? The length of that is 1 or unity. Then for any distant theta, we can find this, use this expression. So this means that if you had angular velocity, if you had a revolute joint, basically, right? If you have a revolute joint, e to the power of s theta is going to be a big matrix, e to the power of skew symmetric of omega times theta, 0, and then that big expression 1. Things that I want you to pay attention to are, don't forget there's a v here, which is this v, right? Linear velocity. Also note that e to the power of omega theta is omega theta, because theta is a fixed number. You can bring it inside or outside of the matrix, skew symmetric matrix. This is identity, and this is the skew symmetric. 0 and 1. Now, if you only have prismatic, so you don't have any angular velocity, then you can use this. This comes from here, just omega is 0. So you can directly use that. So this, if you just remember this, you can basically put omega 0 and then you get to the second one. These are things that you want handy, but you will get to code this. So you'll just write a code and it just, you can just use that from there. All right, will be our next week's assignment. I just have to write it. All right. Theta is your joint variable, right? So when you have prismatic, that becomes D. Don't forget that. We just call it D, but theta or D are joint variables. So if you have 6 joints, you're going to have 6 screw axes. You're going to write e to the power of S1 theta, e to the power of S2 theta, and then in forward kinematic, you multiply them, right? Remember that expression? So to find, so what I'm talking about is, if you remember theta, T of theta, the transformation expression that you show your forward kinematic was e to the power of, for example, S1 theta 1, S2 theta 2, done, Sn theta n times m, right? So for every single one of these, you have to go solve that. That's 4 by 4. And you're able to, this multiplication, this is also 4 by 4, you get that theta. So that will be 4 by 4. Here you have R, you have P. So it is your final position orientation of your arm or end effector, basically. So for exam and for the assignment, for your homework, you don't have to do this. This is just for next week's programming assignment. All right. So if you go back to this. If you have questions, you can ask me. Now, this is the question that I given you, and I ask you to do it. If you haven't done, just follow my lead. All right. Make sure you know where the information in your lectures are. So the question here is find home position for end effector. I just show EE for end effector, right? So that is M. And then find SI screw axes for each joint. So for this question, I'm only asking you to find 2 things. I'm not asking about forward kinematic expression. So you should show me understanding that you know what I'm asking. The previous example, I asked for expression for forward kinematic in the example that what day is today, Friday? On Wednesday. If I ask for expression for forward kinematic, you have to calculate bracket S and then write this expression, right? So this is bracket S, sorry. So that is the expression for forward kinematic. If I ask only to calculate SI, which is a screw axis, you'll do what I did here. In your homework, I've asked both of them, all right? Just make sure you know which one is which. So you're showing your understanding of this question. Now let's find M. M is the home position. Let's say this is home position. This is our end effector. So frame B is on end effector. This is frame S. This is our base. And as you can see, this frame goes through the base. You can assume the first 3 joints are coinciding. Bad handwriting. coinciding. So they are on top of each other. So this like skinny line there is just to show you, to separate them. But in reality, there are three joints that are on top of each other. They're connected. All right. So you remember that, for example, if we have RR joint that rotates around two axes, when we are trying to analyze, we separate them to R and R. That's why we show them like this. So in reality, these two are actually a joint that looks like this, can rotate about two axes. Okay, but for analysis, we separate them. And then those skinny lines are, hey, these two were on top of each other. I just put them aside so I can see the rotation axis. There's no distance in between them. If there was a distance, you will be given, for example, here. All right. Now, what is M? So this is your S frame, this is your B frame, and you have the distances. Let's go with,
Question about the distance.
yeah.
So the L1 passes through a prismatic joint there. So isn't L1 variable?
Again, the two rotating joints are on top of each other and they are on top of the prismatic. The prismatic moves those two. So the beginning of this three joints that are coinciding is the start of when you calculate Q for your other joint. Let's 4 here. Let's make it easier. Assume the first 4. Would that help you?
So you think that L1 only starts at the
So L1 starts here, okay? All of these are connected to each other. They're all on top of each other. Look at my shoulder. This is a 3R, right? If I wanted to analyze, I would divide this into 3 different joints. I would show them with little lines in analysis. But in reality, they're on top of each other. So this is the same. There are 3 R joints plus prismatic. The origin of their frame is in 1 point. So the next joint is measured from the origin of this, the origin of the next joint. Okay.
Yeah, I just have internally I was just struggling with the idea of a prismatic joint being coinciding with the
So imagine my shoulder, something like a 3R, like a ball ring. It's connected or placed on top of a slider. The slider is moving, those 3 are moving too. Does that help? Like a cart and a pendulum that can rotate in all 3 axes, they're moving together. That is this configuration. Okay, so when it gets to 3D, visualization might not help you as much. Trust the diagram. Because usually when there's a robot, you convert it to diagram, then you start analyzing it. You don't analyze what you see because you don't exactly know how it works. So this is like an exploded version of that. All right. So assume those 4 are all connected. So the information tells you that Q for those 4 is 0, right? Now, what is M? Anyone? What is the rotation of your S frame, Justin? Great. All right. So this is M. Now we have 6 screw axes to find, right? So create a table. I, omega I, QI, and then VI. Remember that VI was negative omega I cross product of QI plus V prime. I'm going to call it V prime I, which is if it was prismatic. If prismatic, we only have linear velocity, right? So joint 1. One more thing. From now on, every time you see a rotation, that rotation is happening about the z-axis of that frame. Meaning here, this is your Z1, if this was theta 1. This is Z2, theta 2. Here you have D3, right? So this is Z3. You have, this is theta 4, this is Z4. This is Z5, this is theta 5. This is theta 6 and Z6. So that's prismatic zones, there's no rotation, but that's our D, right? It's always in the direction of the axis. All right. So it's implied. You might not even be given, but when you see the direction, you should be able to use your right hand rule and find that. Now, omega 0 is 0, 0, 1. Can you see that? In Z direction. Then Q is 0, 0, 0 because we said they're on top of each other on the frame. And then here will be 0, 0, 0. 2 is 1, 0, 0, 0, 0, 0 still. Now, 3, tell me about 3. What is omega I for third join? Alex. Yeah. I remember it was your birthday. This is love. So what is omega 3? What's angular velocity of the third joint? What kind of joint is third joint? What's angular velocity? What is angular? Define angular velocity. Yeah, I know, like if you were showing what is angular velocity? This is linear velocity, right? What is angular velocity? I'm asking you, is it? Is it not? No. So angular velocity is this, right? Then you rotate. So if you have a prismatic joint, your omega will be 0. So easy. So when you see prismatic joint, thank God, because now we don't care what Qi is because we don't have negative omega I times Qi. We only have V because of the angular velocity. Now, what is your V? Cam? Yeah. V of D3. 0 is correct. Look at Z3. Look at Z3 and then check your S frame and see in what direction that Z3 is. So 1, 0. All right. So that's how you find V. I'll just write the rest of them. The rest of them are just easy because there are rotation, revolute joint. We already done it. So here is 0, 1, 0. And then C4. I'm gonna put 0, 0. My solution is a little bit because I assumed here 4 joints are coinciding. But if it was 3 joints, like example I solved on Wednesday, the beginning of this would be from L1. But for the simplicity here, whatever this is, I don't know. Probably 0. Yeah, it is 0. And then fifth, 1, 0, 0. And then it's 0, L1, 0. And here, 0, 0, negative L1. For this one, 0, 1, 0. 0, L1 plus L2, because it's just that distance. And this guy is 0, 0, 0. I need to check this one. So, but whatever. Let's say that is correct. Now, I'm not done yet, right? What do I have to do to finish this example? S1 is this guy and this guy. 0, 0, 1, 0, 0, 0. So this is the screw axis of the first joint. S2, 1, 0, 0, 0, 0, 0. S3. Here you can see. So if I give you a screw axis For example, if I given you this one and ask you what kind of joint this is representing, you should be able to tell, right? Because these are all zero. This must be mathematics. If I given you this, you wouldn't know if there was any other velocity involved, but this is for sure, this is mathematics. And then S4, S5, S6. Right? You just grab omega I, boom, VI, boom. Cool beans? Make sense? Yes. Yeah, I know the annotated one is that this one might be wrong, annotated. Because I didn't connect 4 or 5. Yeah, 4 or 5 are connected, but for this, because Michael asked question, I connected the first 4. Yeah. The annotated version of Wednesday is a different robot. So, because I was just explaining to you how 4 of them could be connected to each other. Was that you? No, was sorry, Michael. Yeah. So I will fix this for this annotation, so you'll see. So on Wednesday's annotation, I assume 1, 2, 3 are on top of each other, 4 and 5 are on top of each other. So L1 is the distance of 4 and 5 from the base plate. And so I will always tell you what to assume. So for example, for class participation, I told you what to assume. All right. Since we don't know, this question didn't have any assumption, I can assume anything. But as your teacher, I will tell you, teacher, what to assume. Okay, so it's easier for you and not confusing. All right. Any question on yes?
For Q3, would it be wrong to write down 0, 0, 0 there?
Okay, but there's no point of yeah. That's why I didn't bother to write, but it's not wrong. Yeah. Sweet. Yes.
So Q is the sort of displacement from the original.
The offset, the distance between the frames.
So for something like C4, that would be 0, even though it's.
Yeah, it's going through. Yeah, it's going through the. Yeah. So for Z4, so you see Z4. If Z4 was here, yeah. Here, look at this. If Z4, like the assignment on Wednesday, was if these two were on top of each other, then the base of this will be L1, right? This is what I solved on Wednesday in the annotated. Here, I said, you know what? Let's say this is a different robot. Let's say these are on top of each other. This arm, my arm, and this sliding joint. Then that's a different thing. But I can, if I don't tell you what, you can say this is, there are 2 configurations that could exist. And gives you different kinematics.
So Z4 would have a Q of 0, but then even though it's basically the same.
The frame of Z6 is here. So look at the origin of the frame. Don't look at that the joint is laid down vertically or along the axis or not. This is a rigid body, right? For every rigid body, we need to assign a frame. We need one point that we can make measurement based on that. So the frame that I connect to this will be in front of this joint. Doesn't matter how long this joint is. I'm interested in the direction of the rotation. Okay, and Q is always the origin of that frame that you assign to your base frame, the original base frame. You will see that in the next method here, we will get the ZS some random place. And you just have to calculate to that random place. All right. Raise your hand if you're using iPad today. Okay, raise your hand if you're using paper. And now, those of you, keep your hand up. Raise your hand if you don't have pen and paper. Like you have your phone and not looking. 1. Yes, it's suspicious. Quiz. I'll take these with me if it's paper. If it's You can also submit an appointment. You have half an hour. This is open book, open lectures, not open book. You can look at your lectures. You should not look at your book. So for this one, these three on top of each other, so ignore this guy. This is just to show you this is connected. These three are on top of each other. And ignore like these lines. This is just to show you they're connected. Solid distance is LLL between the three of these. Oh. None of them are prismatic. They're all removed. So that on frame one is like connected to ground because this one is not removed. Grounded. You don't do this, well, it will be grounded. So this is your S frame. This is your B frame. This is just ground. So